In the last video, we looked at an example of how to conduct a chi-square test of independence. In this example, we're going to take an instance where we have raw data collected on two categorical variables. And the context of the data is centered around an article in the USA Today, which reported that on a study conducted by Daniel Vinson on the relationship between anger and propensity to be injured. This is sourced from Steven Sternberg, uh, and the title of the reference paper here is Study Angry People Are a Danger to Themselves. And the data set is contained in our Unit 10 data set, which contains data on the emotions reported by a sample of patients just before they were injured. Now, a very good way to start off with some descriptive statistics on the data is to use the data in the file to construct what? A contingency table. Now, let's take a look at that data set. So I have the data set in StatCrunch ready to go. So you have severity and you have emotions. This is talking about the severity um, of the injury, and these are a different range of what emotions felt before an injury. So let's look at the distribution of the different levels of each of these categorical variable. We can go to Stat, and we can go to Tables, and in particular, we want a contingency table for data. So I can go to data and my row variable. If I want to replicate exactly what I have already here, I would like my row variable to be severity and emotions to be my column variable. That is just a matter of, random pick. Either one can go on either dimension. So going back, I'm going to say row. For the row variable, we have what? Like we said, we have severity, and the column variable is emotions. Okay, and if we want, we can look at the expected count. It can do that too for us. That is really nice. What we like to do is a chi-square test of independence. So I have expected count, chi-square test of independence, and that the 95% confidence level, which means you have 0.05 level of significance. Click on compute, and we have it done quick. So here I have the contingency table, where for the rows we have the different levels of severity of the injury, and for columns we have the different level of what? Emotions. And the good news is we can also get the expected value whenever we're dealing with raw data. So this comes really handy. All right. And with that said, let's go back to our workbook. So we have completed the contingency table, and we can see the tabulation of the data values or data. In particular, we can see that 166 of those sampled experienced what? Anger just before an accident, and they ended up having a little accident. So our interest here is to investigate if there is any connection between these two categorical variables, severity, and what? The other categorical variable, emotions. To do that, a chi-square test of independence can be very, very useful. And so we must also notice that none of the expected values is lesser than 5. That is critical. So as it stands, we can set up the null and the alternative hypothesis. As we illustrated in the previous example, the null hypothesis must be the hypothesis of independence. No connection between both of them. That is assumed to be the status quo. Okay, and the other one, the alternative hypothesis, is that The emotion felt by patients just before they were injured is associated or dependent on the severity of the emotion. Now, based on our output from StatCrunch, we have what? A p-value already provided here. And the degree of freedom should be no surprise because we have what? 4 here. 4 minus 1, that is 3. Then 3 minus 1, that is 2. So 3 times 2, that will give us 6. That is the degree of freedom associated with that test of independence. Then we have the p-value provided here. So back we are here. Now with that p-value and the chi-square test statistic value, we can compare the p-value to the level of significance of the test, which this question wants us to take to be 0.05. Hence what we have here. The p-value is less than what? Alpha. That leads us to reject the null hypothesis in favor of the alternative. And that means that we can conclude on the alternative, which is that the sample data provides what? Sufficient evidence to conclude that the emotion felt by patients just before they were injured is associated with the severity of that emotion. So very, very crucial. And that brings us to the conclusion of that test.